Let's take a few minutes to write down some formulas that are used when we are summing sequences of numbers. Then we'll take a look at a couple examples that are going to be using these. So for our first one, we have the summation from k equals 1 to n of the letter C. C in this case represents a constant. So if I was adding them together n times, that would be the same thing as C plus C plus C, right? A total of n times, or in this case, just C times n, my constant times the number of times I'm adding it together. In our next one, we're going to be starting at a k value of 1 and going all the way up to n, and this time we are summing our k values. So 1 plus 2 plus 3 all the way up to our value of n. In this case, our summation is going to be equal to n times n plus 1 on top over 2. In this third formula, we're going to be summing k values from 1 to n of k squared. So we're looking at 1 squared plus 2 squared plus 3 squared all the way up to n squared. This is going to be equal to n times the quantity n plus 1 times the quantity 2n plus 1 all on top. And we're going to divide that by 6. Let's take a look at one more. And in this summation, we're going to look at k values from 1 to n of k to the third power. So 1 cubed plus 2 cubed plus 3 cubed all the way up to n cubed. Our summation in this case is going to be equal to the fraction n times the quantity n plus 1, all of that over 2, and we're going to take that whole fraction and we're going to square it. Now let's take a look at a couple examples that use these formulas. In these next two examples, we want to find the sum of each of our sequences. So in part A, we have the summation from a k value of 1 to 5, and we're going to be working with our 3k. Let's also use some properties that work with summations as well while we're working through these. The 3 in this case is a constant, and it's going to appear in each of our terms. So I'm allowed to go ahead and pull that 3 all the way up in front. And that's going to give me the summation from k values of 1 to 5 of k. And now we can go back and take a look at some of those other formulas we had, because we already have summation formulas that we can use so that we can rewrite this one. So I'm going to be using this formula that we talked about in order to calculate my sums. I'm going to need my n value, which in our case is going to be a 5. If I plug in my n value of 5, I'm going to get 5 times the quantity 5 plus 1, all of that over 2. That's going to be this piece. And then I still have to multiply that piece by 3. So this is going to come out to give me a 15. And 15 times 3 is going to give me 45. So this sequence should sum up to 45. And for part B, let's take a look at the summation from k values of 1 to 10. And the formula we're going to be working with is k cubed plus 1. Let's also use some properties on this one. Since I have two terms here that are being added together, I can actually break this summation apart into two summation problems. I'm going to break this apart into a summation from k equals 1 to 10 of k cubed, and I'm going to be adding to this the summation of k equals 1 to 10 of that constant 1. So we're going to be using two of those formulas we talked about, one that involves the constant and the other one that involves the k cubed. Here's my two summation pieces I'm going to be working with, and my n value in this case is going to be the number 10. When I'm looking at this second summation piece, my constant, that c value, is a 1. So if we plug in the n value of 10 and that c value of 1, then when we simplify this piece, we should get 3,025. And 1 times 10 is just going to give us 10. When we add those two pieces together, our final answer for the summation is going to be 3,035.